Hi, 7th grade. Welcome to Lesson 6-1, your first lesson of Topic 6, Populations and Samples. By the end of the lesson, I want you to be able to say, I can determine if a sample is a representative of a population. Let's solve and discuss it. The table shows the lunch items sold the table shows the lunch items sold on one day at the middle school cafeteria. Use the given information to help the cafeteria manager complete his food supply order for next week. So it looks like there were 43 turkey sandwiches sold, 51 hot dogs sold, 14 veggie burgers sold, and 27 fish tacos. So what conclusions can you draw from the lunch data? Let's write some things down and get some participation. Okay, so hopefully we got people that said we need to order the most hot dogs and less veggie burgers. You can tell that because you can see that hot dogs were the things that were ordered the most, that people bought the most, and veggie burgers were ordered the least. And you can put them in order. So hot dogs were the most popular, then the turkey sandwich, then the fish taco, and lastly the veggie burger. Focus on math practices. Why might it be helpful for the cafeteria manager to look at the items ordered on more than one day? The more information you have, the more accurate it will be. Okay, example number 1. Understand populations and samples. The 2,468 registered voters in Morgantown are voting on whether to build a new stadium. Morgan and her friends really want the town to vote in favor of the new stadium. How can they determine how the voters will vote before the day of the vote? So how can you represent the problem situation? So Morgan and her friends could ask every registered voter or the entire population of voters in town how they plan to vote. So population, this is one of your vocab words. So that is the entire amount of people. So population is everyone. However, surveying 2,468 people takes a long time. Morgan and her friends may not be able to survey the entire population of voters, so we're going to find out what they could do instead. Morgan and her friends could ask a subset or a sample of the registered voters in town how they plan to vote. So sample is a smaller representation of everybody in the entire town. So surveying the sample of voters does not take as long and is more reasonable to do. Morgan and her friends would be able to ask 100 or 200 people. Let's try it. Miguel thinks the science teachers in his school give more homework than the math teachers. He is researching the number of hours middle school students in his school spend doing math and science homework each night. So the blank includes all of the students in Miguel's middle school. So that would be the population. Remember, population is everyone. Population includes all of the students in Miguel's middle school. A possible sample is some students from each of the grades in the middle school. Now, you wouldn't want to ask just people in 6th grade or just people in 8th grade. You'd want to ask some from 6th, some from 7th, and some from 8th, so you would have a fair population. But we'll talk about that in another lesson. Why is it more efficient to study a sample rather than an entire population? A sample is a smaller amount of people that still represents the whole population. It's more efficient because it would take less time. It's easier to ask 100 people than it is to ask 2,000 people. All right, example number 2. Describe a representative sample. Morgan decides to survey a sample of the town's voting population. How can she know that the survey results from the sample of voters represent the position of the entire town's population? So another one of your vocab words, a representative sample, accurately reflects the characteristics of the entire population. In a random sample, each member of the population has an equal chance of being included. A random sample tends to be a representative sample. So if you're picking people random, that's going to be more fair. You're going to get a sample with people from all different positions. So Morgan can survey a random sample or a randomly selected group of voters to make sure that her results represent the position of the entire town. A produce manager is deciding whether there is customer demand for expanding the organic food section of her store. How could she obtain the information she needs? Well, she could survey a random sample of customers. Because it wouldn't make sense if she just stood in the organic food section and only asked the people who are in the organic food section. Obviously, they would all say, yes, you need to expand it. But people who don't eat organic food, maybe it's too expensive, maybe they don't really care. They wouldn't really want the expansion of the organic food section. So as long as the people that she surveyed were random, you would get a better amount of data. So example number 3, generating a random sample. How can Morgan generate a random sample of the town's voting population? Morgan can follow these steps. Step 1, she's going to define the population. The population consists of all the registered voters in the town. So the first thing we're going to say is, okay, who's the population? Who is everyone we're talking about? Well, everybody who's registered to vote. We wouldn't want to talk to anybody who's not registered to vote because their opinion doesn't matter. Step 2, choose the sample size. Morgan plans to survey 100 registered voters. The larger the sample, the more confident Morgan can be that the results represent the position of the population. So yeah, surveying 2,000 people would be better than surveying 100 people, but she just doesn't have that kind of time. So surveying 100 people is good. It's better than surveying 10. So we defined our population, everybody who is registered to vote. Then we choose the sample size, those 100 people. Now we're going to make or acquire a list of all the members in the population, assign a number to each member of the population, and generate a list of random numbers to select sample members. So it's like picking numbers out of a hat, picking straws out of a cup, or tongue depressors. So let's try it. Ravi is running against 2 other candidates for student council president. All of the 750 students in Ravi's school will vote for the student council president. How can Ravi generate a representative sample that will help him determine whether he will win the election? So our first step, remember, was defining the population. So our population was all 750 students in the school. Then we're going to choose our sample size. So how many people do we want to survey? Our sample size, we can do maybe 50 people. And step 3, we make a list of everyone. Step 4, we can assign everyone a number. And generate a list. Generate a random list. Okay, remember, representative samples are random. Representative, random. You're picking people at random, not on purpose. Example number 4 on the next page. Morgan and Maddie will generate a random sample of the 138 students in 7th grade at their school. They each write the numbers from 1 to 138 on small pieces of paper and put them in different hats. When they draw 20 numbers randomly from their hats, what do you notice about the 2 random samples taken from the same population? What does this tell you about the sampling technique? Okay, so there's 20 members in each sample. The only numbers common to both samples are 38 and 106. That means the numbers are distributed evenly in each sample, so it's going to be fair. Out of all of the numbers, we only got 2 repeats. That's not bad. The sampling method produces random samples that have mostly different numbers, but that are each likely to be representative of the population. The table at the right shows the random sample that Jeremy generated from the same population as Morgan and Maddie's samples. Compare Jeremy's samples to Morgan and Maddie's. So let's see. Morgan and Maddie both had 38 and 106. Does Jeremy have those numbers? I don't see any of them. If we look to see, maybe we can compare Jeremy's to Morgan's and Jeremy's to Maddie's. Do we see any repeating numbers? I see that Jeremy and Morgan both have 36. It's hard to tell just by looking. But that just shows us that if we can't spot it right out of the blue, then it is a random sample. And since it is a random sample, it's fair, it is representative. All right, key concept. A population is an entire group of objects, people, animals, plants, from which data can be collected. A sample is a subset of the population. When you ask a statistical question about a population, it is often more efficient to gather data from a sample of the population. A representative sample of a population has the same characteristics as the population. Generating a random sample is one reliable way to produce a representative sample of a population. You can generate multiple random samples that are different, but that are each representative of the population. All right, 7th grade, let's say it. I can determine if a sample is representative of a population. Have a great day.